Hi everyone. Today we're going to learn about a new family of functions called logarithms. They're going to be used for many features. We're going to use them to graph. Mostly we're going to use them to solve. So we're going to start with exploring this equation. 5 to the x power equals 50. Now I know 5 squared equals 25 and 5 cubed equals 125. I could graph the exponential and the linear functions and see their intersection and what x coordinate that is at. I can't take the square root because I can't take the x root, or I don't know what x is. I could guess and check my way through it, but we're going to learn that there's something called a logarithm that we can use in order to solve that problem without guess and check and without graphing. So what a logarithm is the inverse of an exponential function. So if we have the equation b to the y equals x, we can convert it into a logarithm equation so that we undo the exponent. So b down here is called the base. X has got a special name, it's called the argument. So this is read log base b of x equals y. Now the base can be any positive number, but it cannot be 1. If it's 1, then the function is linear. So b, you're going to see it's a lot of numbers. You're going to see a very common number that we're going to talk about. So a logarithm is an inverse to the exponential. We can convert from an exponential to a logarithmic function, and sometimes one is more useful or helpful than the other. Now, something really important we have to see is the general logarithm has base 10. So if you don't see a number down here, it's automatically 10. Just like the square root, the number outside the root was 2. Log base 10 of x. Base 10 is really nice. We have 10 fingers. Counting by tens is nice. That's why we use base 10. So goal 1 is always, if it's in an exponential form, we may want to put it in a logarithm form. And if it's in a logarithm form, we may want to convert it to an exponential. So to convert log base 10 of 10,000 equals 4 to an exponential, the base is 10, the exponent is 4, so we have 10 to the 4th power equals 10,000. So both these equations are true statements. The log base 10 of 10,000 equals 4. You can put that in your calculator and check. You put log of 10,000, hit enter, you get 4. And same thing with 10 to the 4th, it gets you 10,000. So now we can evaluate some logs. And since your calculator only has a base 10 button, when you hit log, we have to understand what these questions are asking. So this question is asking 4 to a certain power equals 16. 3 to a certain power equals 27. And 10 to a certain power equals this really big number, which looks kind of like a million. So the answers, 4 squared equals 16. So log base 4 of 16 equals 2. 3 cubed equals 27. And 10 to the 6th power equals 1 million because there's 6 zeros. So sometimes we can evaluate logarithms without using a calculator. In future lessons, we're going to see how to change the base and how to solve with this, but right now we need to be able to convert from an exponential to a logarithm and evaluate certain logarithms by understanding they are just exponentials in a slightly different looking form.